In today's lesson, we are going to be looking at 3D trig problems. Now, this is going to be kind of similar to our two-dimensional trig problems in that we're going to be using the same kind of ratios and laws that we did with our two-dimensional problems. But now we're going to be kind of combining those 2D problems to form or to help us solve three-dimensional problems. So it's just an extension of it, not learning any new ratios or any new laws or any new calculations, just different combinations of them to help us solve these problems. So in our first problem, a radio antenna lies due north of Sam's house. Sam walks to Elena's house a distance of 1,200 meters, 50 degrees east of north. From Elena's house, the antenna appears due west with an angle of elevation of 12 degrees. We want to determine the height of the antenna to the nearest meter. So I have this image already drawn out here. We have a picture of this image, and we want to find this height. Right? We want to find this height of the antenna. And we can see a triangle that is a part of. Right? It's a part of this vertical triangle. It is a right angle triangle because a vertical antenna will form a right angle triangle with the ground. And we can see we're given an angle, this angle of elevation of 12 degrees. So if I were to look at that triangle separately, I'm just going to draw it off to the side here. Oops. We're looking for this height. We know this is 12 degrees, and that is it. Right? That is all the information I have for this right angle triangle. Based off of the way it is right now, I don't have enough information to actually go through and solve for that height. Right? I need a side length of some sort. And that's where the three-dimensional part is going to come into play. So that's a vertical triangle. If I look back at my image, I can see that there is another right angle triangle along the ground between the houses, or the two houses, and the antenna itself. And it forms this right angle triangle where we're given an angle and we are also given a measurement. So if I were to redraw that triangle, draw it out to, not to scale, but at least kind of how it's laid out. So right angle, we have 50 degrees, and we have 1,200 meters. So based off of that triangle, there's enough information. I do have enough information that I could go through and find any of the other two sides of that right angle triangle because I have an angle and a side already. And now when I look at these two triangles, they do share a common side. Both of these triangles share this common side that I'm highlighting right now in green. Right? If I look at the diagram, right, I can see that common side as well. I'll highlight in pink, right, that common side there. Right? So they share that common side. Oops, is it not? And so because they share that common side, if I find it for one triangle, I'll find it for the other. Right? And once I find it for the one, that will give me enough information. So a lot of what these 3D problems are basically using the triangles that we have to find as much given information or as much other information as we can. And hopefully it's for a common triangle or a triangle with the missing piece. So in this case, I can find this length of the triangle or this other unknown length. We'll call it X. I'll label my two triangles. And when I find that side in one triangle, it also happens to be shared with another, and that will be enough information then to go forward to find my height. So the first thing we're going to do, our step one, we want to find the distance from Elena's house to the antenna. So I want to find that distance. So that's that one missing piece that I'm going to look for. So I'm going to draw out that triangle again just so I have a reference as to what I'm looking for. 100. We know we're told that it's 50 degrees. I'm looking for this unknown side. So based off of that, because it's a right angle triangle, I can use my trig ratios. Right? So I'm looking for the opposite. I'm given the hypotenuse. So in this case, I am going to use my sine ratio. So sine theta equals opposite over hypotenuse. Sine of 50 is equal to x over 1200. So I want to solve for x. This 1200 is going to come up, and I'm going to multiply it by sine 50. So 1200 times sine 50 equals sine x, equals x. And then I have 919 meters equals x. So that calculation gives me a distance of 919 meters. So I'm going to go back and add that to all of my diagrams. 919, 919. So now that I know that piece of information, right, it does give me enough in my right angle triangle, that vertical one, to help me find my height. So we used one triangle to calculate another length, which I can then use in a different triangle to help find another length. And it just so happens that those two triangles help form kind of a three-dimensional image. So really, it's not anything new. It's just kind of these combinations of two-dimensional problems. So the next step, or the last step, is we're going to find the height of the antenna. So we're going to find the height of the antenna now. And that's going to use this vertical triangle. With an angle of elevation, it was 12 degrees. We now know that the base is 919 meters, and we're looking for the height. Based off of this triangle, the 12 degrees is my reference angle, so the height is going to be the opposite. The 919 is going to be the adjacent. It is a right angle triangle, so I can use my right angle ratios, or trig ratios. Opposite over adjacent, or O and A, is going to be tan. So tan theta equals opposite over adjacent. Tan of 12 degrees is going to equal opposite, or h, our unknown, our height, over 919. I'm going to bring the 919 up, multiply it by tan of 12 degrees. That is going to give me my height. And altogether, I end up with h is equal to 195 meters. So, therefore, the antenna is 195 meters tall. So, even though it might have seemed complicated at first, we just used our 2D trig to help us find different side lengths. And then eventually we find the height of the antenna. Right? So it's just basically these combination of 2D trig types problems. Right? So again, nothing fancy because it's three-dimensional. It's just kind of a different way of thinking about it, or a different way of viewing the two-dimensional problems. The next example, so Carter is flying the Carter copter, right? If you're not sure what the Carter copter is, it's like a helicopter. Think of the Peter copter from Family Guy. He reports his position is located halfway between Elephantville and Foxtown. So that is this location of J here. Right? That's where he's located, up in the air at an altitude of 1,500 meters. Now Foxtown is located 16 kilometers east of Duckburg. So we have town F is 16 kilometers east, and Elephantville is 16.5 kilometers from Duckburg, so this bottom line here, right, in a direction 42 degrees south of east. So 42 degrees is this entire measurement here, this angle. And we want to find what is the angle of elevation seen from Duckburg to the nearest degree. So basically, what is the angle of elevation that we can see the Peter copter or the Carter copter, right? So that angle of elevation, it might be kind of hard to see. It's this little angle in here, right? So that's what we're looking for, this little angle going from these two lines, right? And it's going up to J, right? So that angle is what we're looking for. Now this one's going to be a little bit more complicated because of all the different pieces. But again, right, hopefully we at least see two triangles here. Right, we see this kind of larger triangle along the ground. Draw it out roughly. And then we have a vertical triangle, right, going from the town to a helicopter in the sky. Forms a 90-degree angle. So I'm just going to relabel our information that we're given. Don't know what that angle is. We know this is 16. I'll label the points as well. D, G, J, D, F, E, 16.5, 42 degrees. So those are the two triangles. Now, looking at these triangles, we have to think, okay, is there a common side that's shared between them? Now, right now, there's not, right? Not between these two, but we do see that DG, right, this line along the bottom here, is the only line or the only side that's in common or touching the triangle on the bottom. So chances are I am going to have to find side DG at some point. And so that means I'm probably going to have to use information in this larger triangle along the ground over here to help me with that. So let's just try to fill out the rest of the information for this triangle DEF, the one that is on the ground, made up of the locations of the three different towns. Right? So based on what I have, right, I have a side, angle, side. So the only other information that I can use right now is I can find this unknown side here, EF. And that's going to be our first step. So our first step is we're going to find the length of EF, right? So this side, this one long side. So because I have that sandwiched angle, I am going to use my cosine law, right? And if again if you want reference on what the cosine law looks like, please go back to the previous lesson. You have the formula there. We've looked at some examples. Right? But the cosine law in this case, side D, which is the same as EF, right? Opposite of the angle. So angle D is 42. So side D is opposite of that. So D squared, or that side length squared, is going to equal E squared plus F squared minus 2EF times cosine D. D squared is going to equal 16 squared plus 16.5 squared minus 2 times 16 times 16.5 times cosine of 42 degrees. So all I'm doing is just plugging my information into cosine, or into the cosine law. D squared is going to equal 135.86953. I want to try to avoid as much rounding as possible as I go through these types of questions. And finally, I'm going to take the square root of that. I get D is equal to 11.7 kilometers. So I now know 11.7 kilometers is that distance. So now I know 11.7, right? So now I know that other side length. Okay, is there anything else I can do now? Well, another thing that I could do is still looking at that triangle. I still don't have enough information to help me figure out that height or that angle of elevation to the helicopter. So let's keep trying to fill out information on this triangle between the towns. So on this larger triangle on the towns. Based on what I have now I do have a full pair and half pairs. So I can find the other angles in my triangle, right? The triangle on the ground, and that's going to be my next step. So now step 2 I'm going to find an angle, other angles in this triangle. Specifically, I am going to look for angle E. Right? And again, that's just kind of because I know what we're going to be doing next. You could be solving for angle F and then find angle E. But again, we do want to, we should kind of see, looking at this diagram, that, okay, if I do have a triangle that shares a common side with that right angle triangle, with that missing side I'm going to have, I should have angle E at some point. Right? So I am going to look for that now. So I'm going to look and try to solve for angle E. And as we just mentioned, we do have enough information that we could use sine law. So I'm going to use sine law in this case. You could use cosine law. I like to use sine law a little bit better. It is a little bit easier in terms of the calculations. Less information you have to plug in. Maybe a little bit more manipulation or rearranging of the equations, but less substitution. So for sine law is a ratio between a side and sine of its angle between all three pairs. So we have side E over sine E, which is equal to side D over sine D. Lowercase letters, remember, represents the sides. So side E is 16 divided by sine E. We don't know the angle, and that's going to equal 11.7, which is side D over sine 42 degrees. Next step, we would cross multiply or start to isolate for sine E. So I'm going to isolate, we're going to have a cross multiplier, so we're going to have 16 times sine 42 is equal to 11.7 sine E. I'm going to divide by 11.7 to get sine E by itself. So 16 sine 42 divided by 11.7 is equal to sine E. I'm just going to bring this up here just for sake of saving some space. So I have sine E is equal to all of that. To get E by itself, I'm going to have to do the inverse eventually, but sine E equals 0.915. So that's 16 sine 42 divided by 11.7 equals 0.915. To get E by itself, now we bring the sign over and do the inverse. And we get E is equal to 66 degrees. So now, if we go back to our triangle, now we can go back. Now we can add in another piece of information, which was 66 degrees. I'm also going to add that into this purple triangle, just so we have an idea. We also have 11.7 for this entire length here. Now I'm going to start to kind of focus in. I'm going to try to move away from this larger triangle, and I'm going to focus in a bit more on this smaller triangle, DGE. And I can do that because, one, I have angle E, and two, I actually have this side length right here. And that side length is actually half of 11.7. Because it was already mentioned that the Carter copter or the helicopter is halfway between those two towns. So if I know that the entire distance between Elephantville and Foxtown is 11.7, then half the distance, I'm going to bring this back over here, 11.7, right, is this entire distance. And half the distance is going to be 5.85. So I can actually focus in on this newer triangle, DGE, and then let's draw that out. So for step 3, I'm going to draw out that smaller triangle. I know 66 degrees, 5.85 is the length, 16.5 is the other length. I don't know what the other two angles are. I don't want to assume that they form a 90-degree angle, and I don't know how it's going to bisect that angle of 42 at the top. So this is all I know for sure. But that is enough information because it actually does turn out that that angle, that side DG, is shared with that triangle that we're looking for. Right? So those two sides now in these, I have a triangle now that has a common side with the triangle I'm looking for. So I can actually go through now, and that's going to be the next step. I'm going to try to find the length of DG. So I'm going to try to find the length of DG. I'm not going to assume that it's a right angle triangle. I do have a side angle side sandwich, or a sandwiched angle. So I can use my cosine law very similar to what I did in step 1. So I'm solving for, again, in this triangle, it is considered side E. So E squared is going to equal D squared. It's a different D from the other one because of the triangle, but it would still be technically labeled side D. Right? So D squared plus F squared minus 2DF times cosine E. Right? So as long as we're just aware that these measurements are going to be different from step 1 because it's a different triangle, even though we have the same kind of labels. So E squared is going to equal 5.85 squared plus 16.5 squared minus 2 times 5.85 times 16.5 squared times cosine 66. Go through that calculation. I get E squared equals 227.95. Square root that answer to get E, which is 15.1 kilometers. So 15.1 kilometers is that length of DG. I'm going to go back in, put it back in with this larger triangle, 15.1. Right? Now that I look at that right angle triangle, now I have enough information here to find that angle of elevation. So now my final step, step 4, we're going to find the angle of elevation. Right? I don't want to call it angle D, we'll call it angle JDG. So we want to reference the sides. I'm going to draw it out roughly, just a quick one, just so we have some measurements. So we don't know what the angle is. We do know that it's 15.1 kilometers along the bottom. We do know that it is 90 degrees. The height of this triangle is 1,500 meters. I do want similar units, so I have to rewrite that as 1.5 because the other one is in kilometers. Based off of the reference angle, I have the opposite and the adjacent. So I am going to be using tan. So tan theta equals O over A, or opposite over adjacent. Tan theta equals 1.5 over 15.1. To get the angle, theta equals tan negative 1 of 1.5 over 15.1. And I get theta is equal to 5.7 degrees. So after all that, therefore, the angle of elevation is 5.7 degrees. Right, so a lot of steps here, right, but the idea is, I'm sorry, I'm just kind of making some lines a little bit neater. The idea is, again, just trying to fill out as much extra information as we can till eventually we can find, we can calculate the measure of a common side between two triangles, between the triangles that we're given and the one triangle that has the missing piece of information that we're looking for. Right? So really, if you're not sure what to do, just start trying to find any missing pieces of information until eventually we can come up with enough information in our one triangle to help find the measure in question. Our last example, right, so this one will be a little bit easier. Right? The last example, a surveyor is on one side of a river. On the other side is a cliff of unknown height that she wants to measure. The surveyor lays out a baseline AB of length 150 meters. From point A, she selects point C at the base and measures angle CAB to be 51 degrees. She selects point D on top of the cliff directly above C and measures an angle of elevation of 32 degrees. She moves to point B and measures CBA as 62 degrees. Determine the height of the cliff to the nearest meter. So again, it sounds complicated, but think of it as a combination of two-dimensional problems. Right, so we want to find, again, the height. So we want to find this height. Now, we see one triangle here that has that height in question. It is a right angle triangle, and we do know that the angle here is 32 degrees. So if I draw that right angle triangle, right, I'm just going to draw roughly, oops, not the greatest right angle triangle, draw roughly what it looks like. I have this unknown height, I have 32 degrees, and that's it. So in order to find that unknown height, I'm going to need one of the other sides. With our right angle trig, I need at least an angle and a side. I don't have the height, that's what I'm looking for, so I need either the hypotenuse or this base. If I look at my diagram, I do have another triangle. Again, the triangle formed on the ground between the 2 points on the side that she's at and the point at the base of the cliff on the other side. So I do see those two triangles. I do have some information there. Right, the two angles, 62 degrees. Maybe that's not the best. I'll go over it just in yellow. I have the two angles of 51 and 62 degrees. And I have a distance of 150 meters. So I'm going to draw that one out separately. Because again, it might be helpful just to see the triangle separately, not as 3 dimensions. So 51 degrees, 62 degrees, and 150 meters. Between these two triangles, they do share a common side. They do share this side. You can kind of see that in the diagram as well, this common side. They share that common side. So if I can find that measure of that non-right angle triangle, I can use that in the right angle triangle, and that should be enough to help me to find my height. So if I look, I'm going to focus on this right angle triangle, or non-right angle triangle, sorry. And the first thing I'm going to do, if we label it A, C, B, right, step 1, I'm going to find angle C. I can do that because it's not a right angle triangle, and I know the other two angles. All angles in a triangle have to add up to 180, so 180 minus 51 minus 62 equals 67 degrees. So sometimes it might be as easy as that for finding extra information. Right? So 67 degrees is that other angle. Now I have enough information for step 2. Now I can find the length of CA. I can find that entire length. I'm going to use sine law, right? Because if I look at my triangle, the CAB one, I don't have a sandwiched angle to find that missing side. I don't have any sides, or I don't have all three sides, which wouldn't matter anyways because I'm not trying to find an angle. So I'm going to use sine law, and I can use sine law because I have a full pair and a half pair. So a full pair, I have an angle and its complementary side or opposite side, and I have a half pair, I have the angle, but I don't have the side in question, which I'm looking for. So I can use sine law here. So sine, or we'll do little c over sine c is equal to little b over sine big B, or capital B. Side C is 150 over sine angle C of 67 equals little b, which we don't know, or side B, over sine 62. I'm going to cross multiply. I get 150 times sine 62 equals b times sine 67. I want to get b by itself, so I'm going to bring the sine 67 over and divide. So 150 times sine 62 divided by sine 67 equals b. This just becomes one calculation, and we get that b is equal to 144 meters. So now that I know that common side, I have enough information in my right angle triangle now to help me find the height of the cliff. And that's going to be my last step. So if I relabel A, C, D, so we're going to find the length of CD. I'll put height of cliff. So now we have enough information to find the height of the cliff. And I'm going to use that angle, or that right angle triangle. So based off of the reference angle, we have our opposite, which is what we're looking for. We have our adjacent. If you don't see what I'm doing, I'm dealing with this triangle up here. So we have the opposite, we have the adjacent, right? So that would be tan. So tan theta equals opposite over adjacent. Tan 32 equals h, our height of the cliff, which is unknown, over 144. We're going to bring the 144 up to isolate h. So 144 times tan 32 equals h. This is now just a calculation. We're multiplying, and we get 90 equals, or 90 meters equals h. So therefore, the cliff is 90 meters tall. So with these three-dimensional problems, right, they're essentially just a combination of 2D trig problems, right? If you think of a three-dimensional shape or figure is just a combination of two-dimensional figures kind of arranged on different planes. So that's the same idea with these types of problems, right? There's nothing new, right? If we look at them in isolated scenarios, it's essentially just asking two-dimensional problems. But when we combine them, right, they then become our three-dimensional problems. So might be a little bit tricky at first, but again, if you're stuck, just try to find as much extra information as possible. Use any trig ratios, use sine or cosine law to help find either unknown angles, unknown side lengths, whatever you can, till eventually you find enough information or find a common side with the triangle of the missing, that has the missing piece of information, right? So in every example here, I'll go and highlight it quickly here. Maybe that didn't do anything. Here you see in green, there was a common side there, right, between the triangles. Here, there's a common side. Here, there is a common side. So in every scenario, there's probably going to be a common side shared between two triangles, of which we can eventually find the measure using our 2D trig. If you need review of the 2D trig, just make sure you go back to the previous lesson just to kind of review the sine law and cosine law and your trig ratios.